Hi and welcome. In this video, we introduce and discuss one of the most fundamental results in the whole of mathematics, namely the central limit theorem. Recall that under weak law as well as strong law of large numbers, we saw that if the sample size is large enough, the mean of the sample is staying very close to the mean of the population. And to show that we have created a sampling distribution of the means by drawing multiple samples from an underlying population and calculating the mean every time we select a sample. And in that way, we created a vector of means which has a distribution. And then in that distribution, of course, has a shape. The central limit theorem is concerning with the shape of this distribution. It says that informally that the sampling distribution of the mean will be always normal as long as the sample size is large enough. And this is regardless of the underlying population distribution, whether it's normal, whether it's non-normal, exponential, Poisson, whatever. If the sample size is large enough, the sampling distribution of the mean is normal. Formally defining, consider a sequence of IID random variable xn, that is x1, x2, and so on, with expected value of mu, which we don't know, and a standard deviation of sigma, which is also not usually known. Then x bar, which is the mean of the sample, has a normal distribution with mean mu and standard deviation of sigma over square root of n. Of course, this is under the condition that n, which is the sample size, is large enough. Experiment shows that if n is larger than 30, of course, the sample is random, then your x bar, which is the sample mean, has a normal distribution with mean mu and standard deviation of sigma over square root of n.